You've stood on a beach and picked up a fistful of sand without thinking twice about it. It slips through your fingers in seconds. You barely register it as anything at all. But that sand is older than every story you were ever taught in school. Older than every king, every war, every language, every single human who has ever lived. And if you could shrink yourself down and ride a single grain of it backward through time, you would fall through nearly the entire history of this planet before you hit anything that looked even remotely human. So what was actually happening down there in all that time before you existed? Start with a number that barely makes sense once you say it out loud. Earth is roughly 4.5 billion years old. Now compress that entire history into a single 24-hour day. Humans, all of us, our entire species, don't show up until the very last few seconds before midnight. Everything else, the oceans forming, the first cell, the dinosaurs, all of it happens in the hours before you even arrive. That's not a metaphor to make you feel small. That's closer to literal. You are the very last flicker of a very long story that had already been running for almost the entire day without you. Rewind close to the very beginning of that day, and Earth doesn't even look like a single planet yet. Many researchers believe that early in its history, a Mars-sized body, sometimes called Theia, collided with the young Earth in an impact so violent it nearly tore the planet apart. Debris from that collision is thought to have formed a ring around Earth that eventually clumped together into the moon, hanging in your sky right now. You've looked at that moon more times than you could count. Almost none of those times did you consider that you were looking at the leftover wreckage of a planetary collision that happened before there was any solid ground left to stand on. For most of that day, there was nothing alive at all, just rock and heat and a young planet still cooling down from its own violent birth. Molten surfaces, constant asteroid strikes, an atmosphere that would have killed you instantly if you'd somehow been standing there. And yet somewhere in that hostile mess, something impossible happened. Chemistry became biology. Non-living matter organized itself into something that could copy itself. Nobody watched it happen. There was no one there to watch. But scientists have spent decades trying to reconstruct that moment anyway. Jacques Szostak, a molecular biologist who later won a Nobel Prize for his work, has spent years building simple synthetic cell-like structures in the lab, trying to show how basic chemical ingredients on early Earth could have organized themselves into something that could hold information and reproduce it. His experiments don't recreate the first living cell exactly, but they show piece by piece that the gap between chemistry and biology may be smaller and stranger than it first appears. Not a miracle, a process, slow, blind, and utterly indifferent to whether it worked or not. Once it did work, that first flicker of life had the entire planet to itself for an unbelievably long stretch of time. Billions of years passed with nothing on Earth more complex than single-celled organisms drifting through ancient oceans. No eyes, no brains, no movement toward anything, no fleeing from anything. Just chemistry, repeating itself, generation after generation in silence. Can you imagine that kind of stillness? A living planet with nothing on it curious enough to wonder what it was. To put that stillness in perspective, simple single-celled life dominated this planet for roughly 3 billion years before anything more complex showed up. 3 billion years is longer than the entire span of time separating you from the very first dinosaurs, repeated over and over again, with almost nothing changing on the surface the whole time. If you had been watching from orbit, century after century, millennium after millennium, the view below would have looked essentially frozen. Life was there, it simply wasn't in any hurry. Then slowly, something shifted. Oxygen, produced as a waste product by early microbes, began building up in the atmosphere in an event scientists now call the Great Oxidation Event. For the organisms living at the time, oxygen was closer to a poison than a gift. Entire lineages of early life were wiped out by it, in what some researchers consider the first mass extinction this planet ever experienced, long before anything with a backbone existed to witness it. But other organisms adapted to tolerate it, and eventually to use it, and that single shift rewired what was possible for every living thing that came after. Oxygen-breathing life, the kind your own body depends on every second, only exists because ancient microbes accidentally poisoned their own world, and some of them found a way to survive the poisoning. From there, life slowly grew more complex. Multicellular organisms appeared. Then came an explosion of new body plans in the oceans, eyes evolving independently again and again. shells, spines, jaws. Scientists call this sudden burst of diversity the Cambrian explosion, and in geological terms it happened almost overnight, a mere tens of millions of years compared to the billions that came before it. Predators appeared for what may have been the first time in Earth's history, and prey had to evolve ways to see them coming, or be eaten. That single pressure, being hunted, may have driven more innovation in a few tens of millions of years than the previous few billion combined. And then, in one of the strangest transitions in this entire story, some of those ocean creatures began pushing toward land. Paleontologist Neil Shubin spent years searching specifically for a fossil that could capture that transition, a creature caught halfway between fish and something that could walk. In 2004, his team found it in the Canadian Arctic, a fish called Tiktaalik with a flattened head, a neck, and sturdy fin bones that hinted at the beginnings of limbs. It couldn't fully walk. It wasn't fully a fish anymore either. It was caught frozen in fossil form, in the exact middle of becoming something new. Think about what that means. Every land animal that has ever existed, every dinosaur, every bird, every mammal, every human being who has ever lived, can trace its body plan back through creatures like this. Your arm, your shoulder, the bones you're using right now to hold whatever you're reading this on. All of it echoes back to a fish learning blindly and without any intention at all how to push itself out of the water. Land opened up an entirely new stage, and life spread across it in strange and enormous forms. For well over 100 million years, the dominant creatures on this planet were not anything resembling a mammal. They were dinosaurs, massive, varied, wildly successful, ruling nearly every environment on Earth for a length of time so long it's difficult to fully grasp. Your entire species, and everything that came before it going back to the first primates, would fit inside the tail end of the dinosaurs' reign with room to spare. During nearly all of that time, the ancestors of every mammal alive today, including you, were small. Genuinely small, mostly no bigger than a modern squirrel, scurrying through undergrowth at night while enormous reptiles controlled the daylight hours above them. Being small and nocturnal wasn't a failure. It was survival strategy, staying quiet, staying hidden, staying out of the way of animals that could kill you without even noticing you were there. For well over 100 million consecutive years, that was simply what being a mammal meant. And then, in a single geological instant, it ended. 66 million years ago, an asteroid roughly 6 miles wide struck the Yucatan Peninsula with the force of billions of nuclear weapons. Geologist Walter Alvarez and his physicist father, Luis Alvarez, first proposed this idea in 1980, after finding an unusual layer of the rare element iridium buried in rock all over the world, dated to exactly that moment in time. Their theory was controversial at first. Many scientists resisted the idea that a single random cosmic event could end an era that had lasted so long. But the evidence kept accumulating, and eventually a buried crater matching the right size and age was found beneath the Gulf of Mexico, confirming what the Alvarezes had proposed. That impact didn't just end the dinosaurs, it reset the entire planet's rules. Sunlight blocked by debris, temperatures collapsing, ecosystems that had run one way for 100 million years suddenly broken apart. Almost overnight in geological terms. Picture the actual moment. A fireball brighter than the sun, visible from an ocean away, shockwaves flattening forests thousands of miles from impact. Within hours, the sky itself would have changed color, and within months, sunlight barely reached the ground at all. Nothing on Earth had ever experienced anything like it, and almost nothing large enough to need much food survived it. And here's the part that should genuinely unsettle you. If that asteroid had missed Earth by even a small margin, dinosaurs may well have continued ruling this planet indefinitely. Mammals were already around at the time, small, quiet, mostly nocturnal creatures scurrying at the edges of a world dinosaurs controlled. Without that impact, there's a real chance they would have stayed exactly that small and quiet forever. Instead, the extinction of the dinosaurs opened up space that had never existed before. Mammals, freed from the pressure of enormous reptilian predators, diversified rapidly. Over tens of millions of years, one branch of that expansion slowly developed larger brains, grasping hands, and eventually something that could stand upright and look out across the horizon in a completely different way than anything before it had. That single branch spent millions more years as nothing special at all, just another primate lineage among many, climbing, foraging, surviving. Nothing about those early primates suggested they were destined for anything in particular. There was no arrow pointing forward, no plan unfolding, Just small variations, tested generation after generation against an indifferent world, most of them going nowhere, a few of them slowly compounding into something new. You are the current endpoint of every single one of those accidents. The chemistry that happened to organize itself into life, the microbes that happened to survive their own oxygen poisoning, the fish that happened to push itself onto land, the asteroid that happened to strike at exactly the angle and moment it did. Change almost any one of those events even slightly, and there is no reason to believe anything resembling you would exist at all. That should feel strange, and it should feel a little destabilizing, and both of those reactions are completely reasonable. Because the honest version of your origin story is not a straight line leading inevitably to you, it's a chain of near misses. A planet that could have stayed lifeless, a poison that could have wiped out everything instead of pushing it forward, a rock from space that could have missed. Think about how differently you tend to tell your own story day to day. You probably describe your life as a series of choices, decisions you made, paths you deliberately took. And some of that is true, but sitting underneath every one of those choices is a foundation you had absolutely no say in at all, a foundation that was already billions of years in the making before you were ever born. You didn't choose the asteroid. You didn't choose the fish that crawled onto land. You inherited all of it, silently, the way you inherit the shape of your own hands. And yet here you are anyway, holding a handful of sand on a beach, made of atoms that were forged inside stars long before this planet even existed, standing on a world that spent nearly its entire history without anyone around to notice it at all. So the next time you pick up a fistful of sand and let it fall through your fingers, without thinking twice, remember what it actually took for there to be fingers there to hold it, and a mind behind them curious enough to wonder about any of this in the first place.